दोस्तों वेलकम टू fauzibaba classes. Once again I am back with a very interesting topic of engineering. Earlier we have seen two important methods of non-destructive testing. They were penetrant testing and industrial radiography. These topics were taught in the level 1 concept. Whenever I will get time, I will take the level 2 concept in deep. Today we are going to discuss the third one, which is very important and very useful technique of non-destructive testing, that is magnetic particle testing. Before going to the topic, we will recollect some important facts which we have studied in our schools and colleges. So let us start with the very beginning. This topic is going to be very interesting, very useful and very helpful also for students who are in the field of engineering, production or some sort of servicing. So let us see this topic. Under this topic, earlier we have seen many famous methods are there in the world which are being used for finding out the defects with the help of various entity methods. Today we are going to see magnetic particle testing. In earlier methods of industrial radiography and penetrant testing also, we are seeing that we are not destroying the object which is going to be which is subjected to be tested. In the same way, as it is also one of the part of non-destructive testing method only, the object or the component which is going to be tested will not be destroyed. So let us see what is this. By name itself, you can see this is magnetic particle testing. Somewhere magnetism is going to play a very big role. In our school days we have studied what is a magnet and what are its properties. In that we have studied magnet is a material which attracts the ferromagnetic items towards itself. What is the ferromagnetic items? Which are made of iron and its alloys. These are the ferromagnetic materials. So in the magnetism we have seen, if there is a magnet, suppose this is the magnet, this shows the polar properties. This magnet contains two poles, north and south poles. Let us see its basic properties which will be useful in studying its application in the magnetic particle testing. We know that these north and south poles are at the end of this magnet, bar magnet or rod. Suppose this is a magnet. So there are the magnetic lines of forces which travels from north pole to the south pole. North pole to the south pole, like this. And if you remember, definitely you might have done one experiment in your high school or intermediate college, practical experiments, where you might have placed one magnet and you have poured some iron fillings and you were just tapping to get one pattern of the magnetic lines of forces. I am sure you might have done. The same thing I am going to teach you. So these are the magnetic lines of forces. Outside the magnet they travel from north pole to the south pole, and inside the magnet they travel from south pole to the north pole. Outside they travel like this and inside they travel like this. So what happens? In that experiment you have seen the maximum lines are originating from north pole and south poles. They are originating from north pole ending to the south pole. In between their density is less. The maximum density is at the pole pieces of this magnet. This is the property which we are going to utilize while carrying out crack detection or finding out a crack. So, by this experiment we got one conclusion: the density of magnetic lines of forces are highest at their poles. Means, if the density is highest at the poles, the attraction power, the magnetic force to attract any ferromagnetic material or object will be highest at these pole places with respect to the in between or in the mid places. If you take two magnets in your hand and try to bring them in the contact, they will be just attracted to the pole pieces only. If you bring south to the south, they will repel. Bring north to north, they will. This conclusion that the density of the magnetic lines of forces are highest at the pole pieces is basically utilized in the field of crack detection. So this density of the magnetic lines of forces is called magnetic flux. It is nothing but number of imaginary magnetic lines of forces in per unit of area. It is called magnetic flux or magnetic density. So the magnetic flux is highest at the pole pieces. Let us remember few important things. How many types of magnetic materials are there? First one is paramagnetic. What is paramagnetic? There are certain materials in the world which are weakly attracted to a magnet, towards a magnet, but they are not strongly attracted. So such materials, such components are the components manufactured with the help of some base material will not be suitable for such type of magnetic particle testing, because if they are weakly attracted to the magnet, we were not able to get the sufficient magnetism produced by any method in that particular component. So our test may fail. So this particular type of material, paramagnetic materials, are not suitable for this test. Number two, ferromagnetic material. These are the materials we are interested in to carry out such type of test. By name itself it is clear, they are the materials which are manufactured, which are derived from iron and its alloys, like iron, nickel, cobalt. They are ferromagnetic materials. They are very, very strongly attracted to a magnet. Once they are attracted to the magnet, so their magnetism retentivity is also high rather than the material we have seen earlier, that is paramagnetic. If ferromagnetic material can be magnetized easily, so their retentivity is also there, and that property we are searching for in this type of testing. Next one is diamagnetic material. What is diamagnetic? They are the materials which shows mild repulsion in place of attraction. They show mild repulsion, or they repel to the magnet when they are bring into the contact of a magnetic field or magnet. So they are also not suitable for this type of test. So these ferromagnetic materials and its components will be suitably utilized in, can be utilized in such type of magnetic particle testing. In this topic, where we derived that the magnetic flux density is highest at the pole pieces where the north-south poles are there. So what happens in the case of crack detection? Suppose if there is a rod, this is the component of some sort of engine, we have magnetized it, then due to this magnetic field, north-south poles will be formed and the magnetic lines of forces will start traveling like this, like this, like this, like this. If we pour spray through some iron fillings which are specially designed in a certain shape, diameter, and with the help of certain carrier fluid, so maximum amount of these iron fillings or testing material will be attracted to the test object at the pole pieces. Here they will be attracted. They will be attracted here only, here only, here only, here only. Very minor, negligible amount of percentage quantity of that this iron fillings will be attracted at the mid place due to low or weak magnetic flux or density showing in between the component. But let us imagine a situation that this rod has a minor crack here. What will happen? Those magnetic lines of forces which were traveling inside from south to north in the component, there will be hindrance in their path and there will be leakage of flux density. There will be leakage, breakage or disturbance in the flow path of magnetic lines of forces. Then what will happen? Whenever there is a leakage of flux, there will be formation of again one north-south pole. Due to this crack, the continuity of the magnetic lines of forces was disturbed, causing the leakage of flux in the scientific language, and thus there was the formation of again one new north-south poles that may be in the teeny form or teeny shape or in the teeny quantity. So what will happen? By this experiment we know very well that attraction force of the magnetic lines of forces towards the iron fillings will be highest at the pole pieces like this. Once the new pole pieces are formed due to crack in this rod or component, so again the magnetic particles, iron particles or testing particles, they will be attracted to this place rather than getting attracted to the other normal place. That is our requirement. We wanted to see wherever there is a crack, we wanted to see that these fillings should be attracted to that point. And by seeing itself, we will come to know that here is the attraction of the maximum iron particle. So this continuity is lying here somewhere. And after that, we can distinguish by some other method also. So this is the basic theory of magnetic particle testing by which we are getting the discontinuity or the cracks in a component. These iron particles may be of useful in the white light, and if you need some precision result, you may need fluorescent type particles also. For that purpose, you need ultraviolet light. In that, these fluorescent particles will be glowing, and very easily you will come to know where is the crack in the component. I think by these two figures and experiments, you could come to know what is our basic purpose and how we are achieving our target in this magnetic particle testing. As you have seen in the starting itself, this test can be utilized in the ferromagnetic materials only for the best result, as the magnetism is the basic criteria in that particular component. This method is suitable for finding out the discontinuity or the crack on the surface and up to some extent subsurface or below the surface. Just below the surface if some discontinuity is there, because our basic idea is that a magnetic particle should be affixed, pasted or attracted somewhere. If crack is not on the surface, if it is just below the surface also, then also magnetic leakage will be there and the pole pieces will be formed and attraction will be created. So this method is useful for the surface cracks and up to some extent subsurface cracks also. While as all the NDT methods have got their own limitation in the own field. Penetrant testing has got some limitation, radiography has got some limitation, and this also have got some limitation, as this cannot be utilized for the non-ferromagnetic materials. But penetrant testing can be utilized, industrial radiography can be utilized. So like this, all methods are having their own separate limitation for testing. We have seen and we know also in the topic of electricity, we have studied the flow of charge is called the electricity. Whenever there is a flow of any charge, some electron is flowing, there will be production of the current. And whenever there is a current, there will be magnetic field. Suppose you have some component, you have some cylindrical rod like this. You want to get it checked with the help of magnetic particle testing, you have to magnetize it. For this magnetization, there are certain methods, there are various methods are there as per the shape, size, design of the testing object. Different type of magnetization methods are used. But you have to magnetize that particular component. You have to create the magnetic field around that component or within that component. Then only your purpose will be solved. You can create direct magnetization. You can do indirect magnetization. If you bring some ferromagnetic material in the close contact of a high magnetic field, then also magnetic field will be created around this. Your purpose will be solved. If you pass the electricity around a iron rod, there will be creation of magnetic field. So all these things will be utilized, and as per the requirements, the testing method can be varied, but the basic principle remains same in all the cases, that production of the electricity causes the magnetic field, and whenever there is a leakage of the magnetic field, there will be attraction of the extra magnetic particles, denoting that there is a discontinuity or some sort of defect. That will remain same. In this case, this is the rod and you have placed on a magnetic testing bench. This rod is fixed between the two jaws of a magnetic testing bench. This bench has a provision to hold any type of job. This jaws can be moved to and fro, and there is a certain provision to make a good contact on the both the surfaces to avoid any type of sparking while passing the high degree of current. So this jaw is placed in between that, and the current is passed through this jaw. Due to the passing of this high current in this particular ferromagnetic rod, magnetic field will be created. But what will be the direction of the magnetic field and what should be the direction of the current? These are to be kept in the mind. We have studied in our schools and colleges right hand thumb rule. If this is the direction of the passing of the current, these curling fingers will show the direction of the magnetic field. So if you are passing the current like from this pole to that pole, the magnetic field will be created all around of this object. And if there is a crack or leakage, you will come to know by pouring the magnetic particle, let it be solid or liquid or fluorescent type of. But basic principle remains same. But here you have to keep one thing in your mind, that when your object will not show the crack being the crack itself. Suppose these are the magnetic lines of forces. This is the direction of magnetic lines of forces and this is the object. This is the cross section of object I am making. The crack lies in the direction of this. What will happen? You can understand with the one very good example. Suppose there is a road and you want to do cycling on this. There is a pit along with the length of the road. What will happen? You will just take little turn and you will move away. But there will not be much disturbance in your traveling. But if this pit, crack are in the cross section of the road, what will happen? You have to get down, you have to take your cycle and you have to take the bypass. Like the same phenomena happens in this case. If the crack is parallel to the magnetic lines of forces, this will not be detected, this may not be detected. There is the condition that this discontinuity should be parallel or at least up to 45 degree, then only, because the magnetic lines of forces should cross to the crack. If they are not coming to the contact of this discontinuity, how the new north and south poles will be created? Once the north and south poles not be created, there will not be strong magnetic flux leakage, and once there is no leakage, then magnetic particles will not be attracted. So any object which is subjected to be tested, they are tested in two mutually perpendicular directions, so that if the object was tested in this way, a crack was lying this way, these magnetic lines of forces have crossed, being perpendicular to them, this was detected. But if there was any fine crack lying like this, that might have not been detected, being in the series of those magnetic lines of forces. So this rod needs to be placed in one another direction. In that direction, these magnetic lines of forces will be perpendicular to this cross section, this crack, and then that crack will be checked. So in this field, any item is subjected to be tested in the two mutually perpendicular directions, so that if any discontinuity was got unnoticed, being in the parallel direction of the magnetic lines of forces, will be detected in the another cross section once the magnetic lines of forces are crossing to that particular discontinuity. So this you have to keep in the mind. This objected, there is a provision in such type of benches, once you are tested in this direction, there is a coil available. You can place the rod in between that coil. Again, magnetic coil will be electrified, magnetic field will be created, and the rod will be again magnetized to the direction just perpendicular to the earlier one. By this method, the second direction testing will be carried out. So ultimate idea, we have to check in two directions, two perpendicular directions, so that no discontinuity get unnoticed. Whenever there are big welding sheets are to be tested, there are big sheets, they are welded to each other. This magnetic particle testing is very suitable, because these big sheets cannot be brought inside X-ray cabin. These big sheets cannot be tested with the help of penitent testing effectively, being rough in shape and size. So, with the help of one prod, like this prod is there, they are placed and the current is passed. Once current is passed, magnetic lines of forces are created. And the discontinuity lying in the welding area is magnetized due to magnetic field. Once you pour the iron powders, once you pour the iron fillings over this, they will be attracted to the crack where developed in the welding area. With the help of this yoke instrument, these such type of long welding sheets are tested. They are got tested like this in the section area. This method is very suitable. So we have seen the basic principle of magnetic particle testing. There are certain precautions to be observed. Suppose you are testing this object in a magnetic field. You have created a magnetic field on a bench with the help of passing some current. What should be the parameter? What should be the standard followed, or which will determine that sufficient amount of magnetization has been achieved, which is sufficient to magnetize this much mass, volume, and sufficient and this length of this material. For this, there is a testing object which is called pi indicator is used. Pi indicator is nothing but a test object which has been provided artificial crack lines. If you have magnetized this object, you put this pi indicator in that field. If the at least 6 lines out of 8 lines are showing the indication of the crack, that means your current, thus your sufficient magnetic field is produced, which will be sufficient to test this object, and the result will be correct. So this pi indicator is very important in this field. This test iron fillings are especially designed. They are not in the shape of round, they are not in the shape of cylinder, they are in the mixture of this and this shape, some round, some conical shape, because once you are pouring these iron powders over the crack, if they are all the iron particles are designed in the shape of round or sphere, they will flow away very easily. They may not be attracted to the crack or discontinuity. If you have selected some other odd shape, there will not be flowability. They will not flow. Their flow will be restricted. So again, you may miss the discontinuity. So the mixture of this round and small conical shape are required for this test, so that their cumulative effect will be flowability with some restriction, so that they are easily attracted to the discontinuity and your result is okay. Once you use this liquid pentant testing, they are poured in a carrier fluid. This may be aviation turbine fuel, kerosene oil, or some other carrier, such carrier fluid designated in that particular manual, which is not corrosible to the particular object, and these powders, fluorescent powders, are poured in that carrier fluid and they are sprayed with the help of one spray mechanism or some bulb. So like this arrangement, sometimes you may need this, sometimes you may need this coil, sometimes you may need this prod. These all arrangements are kept in a magnetic particle testing bench, because different methods may be required for the different type of complex shape. Suppose you have got some gears to be tested of one engine, then in this method you have to keep one rod and these gears to be hanged on that one. You cannot supply directly the current in this gear, you have to supply the current in this rod, and due to this magnetic field the induced current will be produced in that gear. Since these components are magnetized during testing, after the test you cannot leave them like this. After that, the demagnetization is essential, because you really do not know what is going to be happen in the future with this particular component. There might be some other workshop activities due in future with this particular component. There might be some grinding, there might be some sort of other experiment. So if your particular item is kept magnetized, and the another workshop man is started grinding, what will happen? All the iron fillings will be wasted to that particular item itself. There will be a problem, the component may get destroyed. Suppose this component is a part of aircraft and you have left it like this, the component is magnetized, you have placed in aircraft, there are certain gyro equipments in the aircraft, they will show error with this magnetic field. Like this, many other complications are there. So after the test, these items to be demagnetized. For this, there is a demagnetization bench is there. In that, component is kept and they are thrown from one place to another place over a rail, and there is a varying alternative current field is there. Due to this alternative current, this magnetized component will be demagnetized. Because let us see what is actually happening in magnetization and demagnetization. We know this is the atom, this is the nucleus, positively charged, negatively charged. Like this, many atoms remain in a component. Like this, many atoms remain. But their orientation, their individual magnetic fields remain in different directions. Once you apply the external magnetic field, or once you pass the current in the particular component, a particular group, a particular set, a particular area of that particular component shows unidirectional magnetic field. That particular section is called domain. It is nothing but a group, a part, a section of some atoms which are showing unidirectional magnetic field. So, in a component, once you apply the external magnetic field, if all the domains, which are nothing but the group of atoms, are shown, are aligned in such a directions or in one directions, this component will show the magnetic field in that particular direction. Actually, at any part of time, all the components, they have magnetic field within there, because all the atoms have north-south poles. All the atoms have positive negative. But since they are randomly placed, they are not aligned, they are not properly arranged, all the atoms are, all the domains are showing different orientation, so the resultant magnetic field will not be shown. For example, you can understand with this example. This is a parade ground of a military stations. Many soldiers are standing here. Many soldiers are standing in a parade ground. Parade is just called but not started. What will happen? This will see this direction. This will see this direction. This will see this will talk to him. This will talk to him. This will talk to him. What will happen? But once a command is given, Savdhan, what will happen? All the soldiers will be looking towards one direction only. That means all the domains are aligned in one direction. This is magnetism. You can understand, this is magnetism. Again, the parade is over. The command is given, disperse. What will happen? All the soldiers, they will look towards its own desired direction, and again the resultant direction will be null. So they will be disarranged, misaligned, de-aligned. So this is the demagnetization. By this example, you can understand very well what is magnetism, what is demagnetization. So you have to magnetize all the component after this test. By this, the basic concept of the magnetic particle testing, I think you have studied. In the next class, I will try to bring one more interesting topic of non-destructive testing, and further the detailed topic or the level 2 topic with all the scientific and mathematical concept of magnetic particle testing, industrial radiography and penitent testing will be taught to you. There is one more topic left which is in my mind, that is industrial radiography with the help of isotope, is also I will teach you very soon. Thank you. Jai Hind, Jai Bharat, take care.